Hello, Miss Cronin here, and we are going to be talking about transformations of functions in class this week. But to start with, what I want to go over is some basic parent functions. So once we know what the parent functions look like, and once you have an understanding of how transformations work, you can graph functions really easily if they're in a correct format. Okay, so let's look at a couple of functions that we've studied pretty extensively. In Algebra 1, we covered linear functions. The basic parent function is y equals x squared, or if I write it in function notation, I can write f of x, which is the same thing as y. Oops, did I write x squared? F of x equals x. So y equals x is the parent function for your linear functions. Remember, linear functions are going to, when you graph them, are going to be lines. And if you think of like our slope-intercept form, there's no b value, so the y-intercept is 0, and the slope is whatever is in front of x, which if there's nothing there, it's a 1. So my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. I keep doing that. Same thing in the other direction. And that is your basic parent function for linear functions. So what I would like you guys to do is pause the video and do these graphs with me. Pause as you need to when you're going through here. If you get behind, then you can pause it. Okay, so anyway, the quadratic function, we studied that pretty extensively. The parent function for quadratics is f of x equals x squared. Graphing x squared, we know that when x is 0, y is 0. When x is 1, y is 1. 1 squared is 1. 2 squared is 4, so when x is 2, we go up to 4. 3 squared would be up at 9, which is off my graph, but it's still a point on the graph, so just remember that that would be where it's heading. And so you end up with this parabola. When you graph a quadratic, you get what's called a parabola, and that is the parent function of the quadratic family of functions. Okay, for cubics, we haven't really done a whole lot with cubic functions, so let's make a table of ordered pairs, and the parent function for cubics, so I'm going to write it in function notation, is just f of x equals x cubed with no additional terms, no numbers added or subtracted or multiplied or anything like that. So let's look at, like, how about we'll start with -3, and we'll pick values of x that are close to, let me add one more column here, one more row, I mean. We'll go from -3 to 3. So if I cube -3, I get -3 times -3, which is +9, times another -3, which makes it -27. That's way off my graph, so I'm not really going to be able to graph it, but if you think at -3, it's going to be way down at -27, so pretty far down on the y-axis. If I cube -2, -2 times -2 is 4, times another -2 is -8. Also off my graph, but not too far. I can probably put that point on here. -1 cubed, -1 times -1 is 1, times another -1 is -1. 0 cubed, 0 times 0 times 0 is 0. And 1 cubed would be 1 times 1 times 1, which is 1. 2 cubed is 8. These are all going to be the exact opposite of when you put in a negative, like a -3. You have 3 negatives multiplied together, so you get -27, but a +3, you have all positives, so it's a +27. So let's graph some of these points. -2, -8 is approximately right about here. -1, -1, 0, 0, 1, 1, 2, 8 is up here, and then 3, 27 is way up there. So it looks about like this. There's your parent function for the cubic family of functions. So let's actually throw a couple of these coordinates on here. And so when we do transformations, if you know those coordinates, it's going to make it a little bit easier to graph the transformations. All right. The next, we're going to do two more here for now. There are other function families, but this is what we're going to start out with. The square root function. So square root function is f of x equals, the parent function is just square root of x. So now when we pick values for x, first of all, you cannot take the square root of a negative number. Remember, it involves I. And so we're going to start out with, let's start with 0. The square root of 0 is 0. So 0, 0 is on my graph. The square root of 1, if I put 1 in here, the square root of 1 is 1. The square root of 2 is, it's an irrational number. It goes on forever, never ends, never repeats. You could grab a calculator and approximate what it is. But let's go with numbers that are easy to take the square root of. In other words, numbers that are perfect squares. So the number 4, if you take the square root of 4, you get a whole number of 2. The square root of 4 is 2. And then the next one would be 9, because the square root of 9 is 3. So I'm going to, and it's already, I'm off the graph, so I could keep going here. The next one I'd want to pick is 16, because the square root of 16 is a whole number 4. And of course there's points in between these ordered pairs, but this will give us a really good idea of what the shape of the graph is going to look like. So I already did 0, 0, 1, 1 is about here, 4, 2 is here, and then if I approximate where 9 is, about there, 9, 3. The graph of the square root of x is actually, it's the inverse of x squared, but it's only half of it, because if I graphed the other piece, x, which is f of x equals negative square root of x, I don't have a function any longer. So when we're graphing the square root, we're just graphing the principal square root, which is just that, the graph that you see there. Again, it's probably going to be really helpful if you label some of these points and just kind of burn them into your brain, so that when you're doing the transformations, you know like where to start, and like what is the domain. You can't put in negative numbers. We start here at 0, 0. And you'll see what I mean as we go through this. Okay, absolute value, the last one we're going to do for right now. The absolute value parent function is just the absolute value of x. And remember, absolute value means you're going to do whatever's inside the absolute value, it's going to be positive. So if we make a table here starting with -3 and go by ones, again I'm going to add one more row. Okay, the absolute value of -3. So finding f of -3, I'd put -3 in here. Absolute value of -3 is +3. Absolute value of -2 is +2. This would be 1, 0, 1, 2, 3. So go ahead and graph those points. -2, 2, here, -1, 1, 0, 0. The absolute value function, oops, I missed it right there. 3, 3, 4, 4. The absolute value function is going to have a V shape like this. So if you know the basic shape of the parent function, and like I said, if you know your transformations, which will be in the next video, you will be able to graph functions pretty easily. Before we go here, let's label some of these points here. When x is positive, the y value is just the exact same, but when x is negative, the y coordinates are exactly the opposite. And that would continue, -4, 4, -5, 5, etc. All right, so that is the basic parent functions. the ones that we're going to be studying for right now at least. And then in the next video, we'll look at how transformations work. All right.